This program has been made possible by a grant from the UCF Office of Research and Commercialization.
The UCF Office of Research and Commercialization is committed to moving the discoveries of our faculty and students from ideas to innovation to realization. By moving research from the laboratory to the private sector, we are helping to diversify Florida's economy and helping to bring high-paying jobs to our state. This program presents some examples of our research and our efforts to transition this research to the private sector.
Hello, and welcome to another edition of Zenith. I'm your host, Ed Hyland, and we have a wealth of information for you today in our program devoted to research. I'll have the latest on a cancer biomarker project that could bring testing for many forms of cancer to your local supermarket pharmacy within 5 years. We'll also hear from a researcher who has created a way to put climate change to the test and is already seeing how at least one creature is changing to adapt. Plus, the second part of my interview with the Vice President for Research at UCF and what we can expect to see in technology transfer. It's all coming up next on Zenith.
If we can make small investments like the Partnership 3 into training and simulation and do anything we can to make the warfighter learn his skills in his complex tasks faster and do them more efficiently, what that will do in the long run is it'll save things like fuel. We'll have to spend less fuel cost for ships and submarines and airplanes. And if we can save energy costs in the Department of Defense, I think we put our nation in a better defense footing.
There is growing concern about the issue of climate change. How fast will it take place? Will it take place at all? If the climate does change, will we be able to adapt? On that last point, a scientist at the University of Central Florida sought to find answers. He created environments based on the best known climate change models and allowed crickets to reproduce and grow in those environments. Even he is a bit surprised at the early results.
We're taking these global warming models and life history model for crickets and sticking them together. What the life history model does is it predicts what how crickets should respond to temperature, when they should lay their eggs, when they should reach adulthood, when they should mate, how they should mate, what sorts of eggs they should lay, and when they should do these. We took the global warming models, which spit out high and low temperatures in the future, plugged them into this cricket model and basically said, okay, so this is how the cricket should respond 10, 20, 30, 40, 50, 100 years into the future. And now what we're doing is, now that we have these predictions, we're actually growing the crickets up in those conditions using incubators to see if they respond how we think they're going to respond. And if they don't, how do they deal with these projected global warming conditions? So we use environmental chambers, and basically we program what the models say will be the daily high and low temperature for every day of the year, and how those change over the course of a season. So it starts off in the spring where it's nice and cool, it warms up over the summer, then as summer it's really, really warm, and then as fall approaches the temperatures sort of decrease. So the crickets are experiencing both daily and seasonal fluctuations in their temperature in an attempt to mirror what environmental conditions they'll expect to see in the future. The crickets in the year 2050 conditions are much larger. They're probably going to reach adulthood a couple weeks earlier than the ones in the 2000 conditions. That was a little surprising. I didn't expect to see that so soon. I expected this to be sort of kind of a flat line and not see any real changes until 2065, 2085, where the models predict rapid increases in temperature. So the best we can do is sort of estimate the rate at which they can adapt to these changes, and then compare that rate at which they can adapt to the rate at which they are going to have to adapt. So instead of adapting to current conditions, they might actually move further north or move up a mountain. And so these crickets are interesting because they have, some can fly and some can't. And so we're measuring gene flow using genetic data, and we're also estimating what proportion of the population can fly. And the thought is, as temperatures get warmer, if more of them can fly, then more migration will occur, and we might see the crickets move further north or further up mountains where it supposedly is cooler than what it will be. And the last sort of mechanism is not really a mechanism, is extinction.
Dr. Winterhalter landed an $860,000 grant from the U.S. Department of Energy for the innovative study. The study concludes in 2011. We now turn to the fascinating study of nanotechnology and yet another way it may be of benefit. Nanotechnology is study down to the molecular level and its very heart, so to speak. A cancer researcher at UCF has found that at that level, she can track cancer almost as soon as it appears in the body. She believes that within a few years, a simple blood screening done at your local pharmacy might offer early treatment options and cures that are not available using current technology.
The precise test, yes.
Dr. Trine Hoa is on a hunt, a search for the trail left by cancer.
Our research purpose is to find a better way so we can detect the cancer. We detect the cancer biomarker.
These biomarkers of cancer are unique to each form of the disease, in this case prostate cancer, and can be detected in the blood down to the smallest or nanoparticle.
A biological cell is going to release different kinds of chemicals into the bloodstream. And then cancer cell, because they're different from normal cells, so they will release either different types of chemical or with substantially increased amount of certain chemicals. So when that chemical gets into the bloodstream, and that's what we're detecting.
Using samples provided by MD Anderson Cancer Center, the cancer biomarker bonds or glues nanoparticles of pure gold together in a process called aggregate. The result literally lights up under a laser scan. Trine has shown she can detect prostate cancer biomarkers and is testing the same process on at least 10 other forms, including ovarian and lung cancers.
So basically, you do one test, you will be able to know the biomarker level of basically all the FDA approved, biomarkers for cancer, for different types of cancer.
A single blood drop can provide all the biomarker needed for testing. Trine believes it can be made into a simple test that could be done anywhere, even your neighborhood supermarket.
The cancer-related protein marker that the gold nanoparticles seek out in Hoa's research is the same one screened for by the FDA-approved prostate-specific antigen test, the PSA test. The PSA has been used by physicians for years, but the new technique is much more sensitive and accurate than the PSA. Still to come, we continue our interview with Tom O'Neill, Vice President of the Office of Research and Commercialization. We'll tackle everything from power patent ratings to technology transfer. Stay with us. The mission of the Office of Technology Transfer at the University of Central Florida is to proactively facilitate the transfer of technology from the university to the commercial sector through enlightened technology transfer policies, processes that efficiently and effectively reduce off-the-shelf technology inventory, and dedication to customers and being easy to do business with. Our guiding principles are development of intellectual property assets, licensing them into the commercial sector, which leads to a return on investment for the university. We envision an eventual contribution to the economic development within the Central Florida region, the state, and the nation. UCF will be recognized as a contributor and leader in the future economic performance of the Central Florida region. Tom, thanks so much for coming back and joining us once again. I want to talk a little bit about where we left off last time, talking about the patent scorecard.
Okay.
First, once again, just to refresh everyone's memory, what exactly is the patent scorecard?
It's a measure of the impact our patents make on future discovery, if you will. It's how many times our patents are cited by other patents, by other inventors, of new patents.
Now, how important is that in terms of rank? It's a scorecard, so there's
Yeah.
a ranking of sorts with the universities, and UCF is in the top 10.
Yeah. Well, it's a symptom or an indication of the quality of our patent in terms of how many other people are building technologies based on that initial kind of platform technology that we developed. So it's good, and it helps the industry move forward with a whole kind of family of patents after that.
Is that important also from, I mean, you're in competition, basically, with other universities, other organizations, trying to get dollars, research dollars. Is that an important factor in being out there and on the sales side of it, trying to bring in some research?
Yeah. It's a clear indication of the productivity of our faculty research, I mean, that's the goal, is to get something out into the marketplace, or get something published or patented that really benefits society. And if it's quoted a lot, it's benefiting a lot of people. So.
Well, one of the areas that we didn't get a chance to touch on before was pertaining to lasers and optics. Let's talk a little bit about, I mean, UCF is nationally, world-renowned really for its lasers and optics programs. But a lot of times when people think of lasers and optics, short of getting something to adjust your eyesight, they think in terms of the military perhaps. Is that starting to change a little bit? Are we starting to see more consumer-oriented products come out of that?
Well, I think people are realizing lasers are kind of everywhere now, I mean, I call it a 40-year overnight success, because lasers have been around for 40, 50, maybe 50 years now, probably longer. And it was an application, or it was a technology looking for an application, and besides the cute little laser pointers and things you can do with them. Now people are really thinking about what they can do to kind of commercialize a lot of the benefits of light, And it is high-speed optical communication. It's the military applications are everything from sensors, remote sensing, to shooting things down, right? And then the same technology would allow you to shoot something down, could let you be focused on something like your body, to do very kind of high-resolution surgery, if you will, to be able to remove materials without damaging the material next to it. These ablative technologies. Again, what I think will be one of the best technologies out of laser will be laser tattoo removal at some point. Right now, they do it by heating up the ink and kind of evaporating it, kind of steams everywhere.
Yeah.
Pretty soon they'll be able to actually.
I understand too.
Yeah,
so.
very painful. Well, the new ablative lasers will actually just remove that material without damaging the material around, or without evaporating, without heating it up. They won't have the thermal kind of problems you have with current technologies. And just lots of good stuff. Spinal cord surgery, you can do things without the new generation lasers will be able to remove material without damaging the stuff around it, which is the biggest problem you have with anything you do for cutting with a scalpel, or cutting with lasers that use heat to do it. So.
You touched also on communications, and I know our friend Peter Delfayette is also often talking about how much data, how much information can be transmitted utilizing a laser beam. Terabits of information done on a single fiber with a single semiconductor laser diode that he's developed over there. Truly amazing. You think about how much information it is, and it's hard to imagine. Yeah, these days with so much of what we do dependent upon data transfer, and everyone, even with home computers, is looking, well, how much faster can I get? Can I get more speed? The fact that something is being developed here at UCF that may have military as well as commercial applications is quite interesting. As
Peter told me, what's the point of having a 100 megahertz computer or a gigahertz computer, and you plug it into a 10 megabyte line? You're kind of, the computer's sitting here and waiting most of the time for something to do if you're on the internet. So these applications that could be kind of improved, if you will, if they can talk to each other at the speed they work.
Another area that has really kind of, I guess, started more on the military side, but has gotten to have commercial applications and gaming applications too, is modeling, simulation, and we do an awful lot of that, and have military partners here at the research park that participate with us.
Yeah, the military, actually, their joint forces across the street spends over $5 billion a year in acquisitions related to modeling and simulation. So a lot of that spills over here. Our Institute for Modeling and Simulation does more than $10 million a year in research, so cutting edge research. And again, a lot of very fun stuff. And the interesting thing about modeling and simulation, it could be used for warfare theater, or it can be used for consumer theater, if you will, right? So a lot of the basic core work you do to make that stuff work can also be used for games. And again, the Florida Interactive Entertainment Academy is an example of us taking a lot of technology, trying to create workforce for EA Sports and people like that in the community that do things like Madden football, you know, really commercial products, if you will. But a lot of it's the same basic technology, you know, it's just making things work better and with a simulation.
You're really on the ground floor for a lot of these things, from patents on up through the process. But are you finding yourself surprised at all with some of the research? I mean, somebody comes in and says, oh, look what I've come up with as an idea. What do you think?
The stuff is just good. You know, I got here in '91, and I used to tell people how amazing it is to walk across campus, see the stuff going on. Now it's amazing how much is going on I don't even know about. I mean, we were doing so much more. I'm constantly amazed at the quality of the folks we've been able to attract to UCF, the work they're doing. I mean, it's world class. It's not the best thing just in Orlando, it's the best thing in the world. So UCF is a gold mine. Getting down to our students. If you look at the quality of our students now, I'm always amazed at how good they are. And everywhere I go, the people that hire UCF students have nothing but good things to say about us. And it all builds. You know, research adds to education and vice versa. You know, the quality of our student, our faculty, is why we do such good research here.
How critical is that? You've touched on it, but I know that I've talked to Mubarak Shah, I've talked to a number of different researchers who will say, you know, I may have a major role in this, but I couldn't do it without my graduate assistants, without my new students, you know, the new exciting minds that come in and really perhaps give you a little different perspective on something you're working on.
Yeah, I mean, it's critical. Most folks will tell you, and it's not a 100% rule, but a lot of the real creative, interesting stuff comes out of your mind when you're younger. You know, but
no, that doesn't happen, does it? No. Not for us getting older folks.
No, but you don't know what you don't know. I mean, so you need someone that's been there and done that, kind of help to guide and channel that creative energy, Will, and then you get the best combination. You put both those things together, and it's amazing what can happen. You know, and the students are learning, they're trying things out. They don't know what they don't know, and sometimes that's good, sometimes that's bad, you know, but depending on, again, what the outcome is. But you want those young folks in the lab learning and building on what you've done. Everybody contributes to the general knowledge, you know, body of knowledge, Will, and it's their turn to come in and kind of create new stuff. And with a faculty advisor and mentor to help them get up to speed, and they take off, and a lot of times they pass, you know, their supervisor, if you will. So that's fun stuff.
How would you rate the current environment for research, in the sense that you know, we're all struggling still with the recession, with a downturn in spending in so many different areas, and obviously that's the life's blood, if you will, for the genesis for the new ideas, as well as taking the new ideas and putting them through to fruition.
Yeah. Well, UCF's been holding our own, I mean, which I think is good. I mean, last time I checked, we're you know, a little bit ahead of where we were last year in terms of our funding. We're not a lot ahead. We've been growing at such a fast rate. It's disappointing when the rate slows down to what normal people's rate of growth should be. But we're growing, and it's really a testament to the quality of what we just talked about, the quality of faculty and students that are here. But it gets harder with this budget stuff because, you know, if our faculty numbers go down, there's less people to do the work, you know, and it just comes to basic stuff. There are other universities that might take this opportunity to try to take some of our best faculty, you know, which, again, we have to be able to be in a position to keep them here, you know, and if you lose them, it hurts, you know. So, but we're lucky so far. I think other people have been affected much worse than we are. I mean, UCF is a place that people want to be here for many reasons, you know, and I call ourselves the biggest adolescent in the world, you know. We're a ground floor opportunity, but in a major university, you know, which is combination doesn't happen very often. So a lot of people are here just for that reason. They know they can be a part of creating something really great here, and it's true.
And you're in a competition, if you will, with other schools to tap into federal dollars, and some of which are really starting to grow in terms of the amount and the direction. How much of that do you attempt to try and find, and how much of it is driven by the government, for example, saying, well, we want people to apply for grants in these specific areas?
Well, certainly the federal government knows what they want to buy. You know, there's regular requests for proposals, and they have it well documented what they're looking for. You know, how well you provide them what they're looking for is how well your funding dollars are. You know, right now it's interesting because there's a lot of people trying to spend a lot of money. So you know, there's all this stimulus money going around, or recovery money, I forget what the correct word is, but you know, so there may be some opportunities for us to increase our funding. Of course, everybody's going to have an opportunity, so we're with everybody else. And the competition for those new dollars may be more than what the competition was before, so it may We may or may not do well. But you know, we're going to try like everybody else does, but we're going to compete on our skills and capabilities, I think, and if we do, we usually do okay.
Is there one specific area that you would say is probably a primary focus for us right now, or is it
energy,
pretty broad-based?
Well, energy right now, you know, is big. You know, again, talking about clean tech, we talked about before, energy, and there's a whole new thing called ARPA-E, which is like the DARPA program, which is the Defense Advanced Research Project Agency. So now there's one dedicated to energy, and they're really trying to do some things with, again, what we talk about with a commercial bent. So if you're going to write a proposal for money to do research, you better have already thought about how you're going to commercialize it. And DARPA itself too has gone that way. You know, you need to have commercial partners now. They just don't want to see it become totally a university research project. You know, they want to see it in the economy, which is you know, where the jobs get created and more tax dollars get generated. It's a good feedback loop, if you will. So
targeted stimulus, targeted opportunities there, so to speak. Tom O'Neill, thank you so much for joining us. And you stay with us. We have just enough time for our Research Minute.
Yes, our interest is to define some of the basic mechanisms in cancer cells, events that have gone wrong in cancer cells between cancer and normal cells, and to utilize that information to derive new approaches for treating cancer. In simple terms, yes, communication all goes on in normal cells as well. However, the difference between normal and cancer cells is that normal cells have regulatory mechanisms. When they require a particular event to take place to grow and survive, they turn on the signal and they turn it off when they don't need it. On the other hand, cancer cells, these communication signals have gone haywire. There are no regulatory mechanisms. Those mechanisms have been destroyed, and so the signals have essentially become deregulated, allowing them to continue to propagate signals to activate the cancer cells to continue to grow and to survive.
And we have run out of time for this edition of Zenith. Join us next month for new stories, new interviews, and new insights into technology transfer. The goal of research is to better understand the world around us. Our goal is to be a window to that world. I'm Ed Highland. Thanks for joining us on Zenith.